Yeah, so this is our LV main switchboard, but this side is HV, isn't it?
It's HV up into the transformer, and then after this switchboard, that's all LV.
So from here back, you're talking about 400 volt nominal.
Yep.
But when you hit the transformer, and then the transformer's connected to the RMU, ring main unit, we are talking about 22,000 volts.
Yep, 22 kV.
So what determines an LV site from an HV site? Because invariably you are connecting to a transformer.
Yes, so the LV site's typically after a transformer in all cases, and they are below 1500 volts DC and 1000 volt AC. That's what this site is.
But if you've got isn't it where what about if I've got and I'm hooking up to say a 16 kV transformer, but it's not on site from my main switchboard, it's still an LV site, isn't it?
Yes.
So is it because
Proximity.
the transformer is the asset, is the site owner's asset?
Yeah, so we've actually got the proximities right here. So this site, they are a HV customer.
Yes.
So the difference is that as they're a HV customer,
they own the transformer.
They own the transformer, not the power authority.
Right, and that's see, this is the thing, and when I've talked to yourself and others about this, it was a hard thing for me to get my head around initially, because eventually everything connects to a transformer and is HV.
Yep.
But it just depends on who owns the HV asset and where it is. So that's something if you're ever considering going down the road of these larger projects, you have to take that into consideration, and you'll have to have someone who knows HV if you're going to do these kind of projects. So let's start up here on this actual enclosure here. We've got a supply authority CT chamber, so that's where PowerCore will put their gear.
That's where the CTs for the generator meter monitor will be installed, and that will be part of PowerCore's infrastructure.
And we've got an MEN link behind this. Is that correct?
Yeah, there's an MEN link on this side because we've got the transformer here. So up until the transformer, it's delta.
Right.
So then we end up with the neutral being produced after the transformer and is linked inside this cabinet.
Okay, that's real. And so the transformer is not delta, it's
star. Generates a star point.
So that's we're talking about the configuration of the actives and the neutrals and the whole bit, how it's actually configured. So are we, or when I say we, Greenwood or the project owner, are they ever allowed to go inside the CT chamber?
Once PowerCore have installed their CTs, no, they are not allowed to go in there without authorization from PowerCore, because the equipment behind there is owned by PowerCore.
So they effectively put their own padlocker or their own special lock system on there and say,
yes, they do.
Bugger off, for want of a better expression. Go away, don't come anywhere near this.
They usually put a tag on it with a serial number.
Interesting. So in this central part, we're looking at the breaker, and in a lot of cases we use motorised circuit breakers, molded case. In this case, it's an air breaker, and I don't really know much about them, but I will say this, that they have a different approach when it comes to derating. You don't have to use a 1.25 rule, and that's according to a few people I spoke. Now, it's got a fairly hefty rating. It's 1600 and 1500 amp, and I've got to ask, you know what, I might sound like an idiot, but hey, this is how you learn. It's got 1600/1500 amp. What does that mean?
The first number indicates the rating of the actual circuit breaker itself. The second number indicates what we've set it to.
Okay, so that's a customized. Yeah, I didn't realize that.
So we're able to change the rating of the circuit breaker by changing several parameters right here.
And obviously the frame rating is around about that 1600, well, around that, it wouldn't be more than 1500 amps on the frame. The frame rating inside where they're actually in the switchboard.
The switchboard will be designed for a 1600 amp. Right here, what have they got it? 1600 volt rated, so they've actually rated the board for 1600.
Okay, yep. And it's a 50 kA for 1 second.
Yep, and they've rated, the board has been rated, so buzz bars inside are rated for 1600, which is if you were to turn this up. So they've gone off the highest possible.
Yeah, and that's how it should be, because again, like a lot of things on these sites, it's weakest link in the chain. You can't have like a cabling that's rated for say 1,000 amps, but you've got a circuit breaker that's rated 1,500. It doesn't work like that.
Work like that.
It doesn't work like that at all. Now I noticed here, there's a little bit of a counter. What is that? What is that? Is that the amount of times it's been switched on and off?
I believe it is.
Yeah, right. I've never seen that. And how accurately, when it comes to actually like dialing it down, because you're not actually physically derating the breaker, you're actually dialing it down. What kind of increments are we talking about with that?
You pretty much set it to whatever you want. This one
Wow.
here actually has an ability to plug it into a computer, and then you can plug your laptop in and physically change all the settings inside.
Wow.
These ones are pretty good. You can set trip curves on them as well.
Wow. It's really, it's such a big thing, because I know if you use a multi-case circuit breaker on a system this size, you'd probably split them up for your interface protection and use like 800 and 800 or something like that, as opposed to one big one, because of there's a few factors that are beyond my level of understanding. But really interesting stuff. Now, the last bit of this enclosure, so there's 3 sections. You got this current limiter, fuses behind panels side. Obviously there's fuses. Give us a rundown of what's behind there.
Each fuse behind here allows us to take the supply to another board. So behind here, we don't have any circuit breakers before the next board on the other side of the cabinet.
Right.
So we've got some fuses here to effectively line tap from this side to supply power up to the other side.
Now I notice also there's some pretty interesting tools, and I can see a key, and I'm looking at this thing. Is this effectively it's just to open, isn't it?
So this circuit breaker is rackable. What that means is we can not only turn it off and put it in the open position, disconnecting the power, we can actually take the entire breaker out. So when you open the door here and you've got it turned off, you can use this tool to unrack it, pull down some side rails and slide the breaker out for maintenance and to create a nice point of isolation.
What do you mean by unracking it? Is it what I think it is, or?
Essentially, it's what you think it is. It comes this entire breaker, it clips in.
Right.
So pretty much by unracking it, you're pulling it off the buzz bars behind it, creating a physical disconnection.
It's like a DIN rail mounted circuit breaker you click on.
Kind of.
Wow, that's really interesting. So I've learned, like always, I'm learning something every day, you know. We're looking here at this particular enclosure. You've got the supply authority CT chamber, you've got the main switch, you've got the current limiting fuses behind panel enclosure section at the bottom, and you've got this filtration system. So is this cabinet passively filtered, or is there a fan inside?
There's actually a couple of fans inside, right in the center cabinet. So it draws all the air through this filter, through the fuse section, through the buzz bar section in between, and then out through the top. So there's some vents down the side.
And its IP rating, I noticed, is
56.
56, so it's sufficient for going outside. And now with these filters, is this something that you see on say a large roof mount system, or is it more like these kind of ground mounts because of their dusty areas?
It's more so environmental. So this area there's a lot of dust, a lot of dirt, debris.
Right.
So depending on where you're installing the boards will depend on the requirement for the air filtration.
So it's all about blocking the amount of particulate matter. Now, these look a bit familiar, and I know you mentioned off camera that these particular filters are used in other industries as well.
Yeah, sometimes the manufacturer of the switchboard will use automotive products. I believe this one's one of those.
Wow. I mean, that's a great use. It's, I mean, at the end of the day, it's a filter, so, you know, doesn't matter if it's automotive or it's in renewable energy.